Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap today. Lots of great information, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand later on. Following today's webinar, we'll be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time today during today's presentation you have a question for either one of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take a few minutes near the end of today's presentation and go through those audience questions. And finally, at the end of today's webinar, we are going to be doing a drawing for 3 $50 Amazon gift cards. So stick around. Hopefully your name will be one of the 3 chosen. Okay, with that, we'll go ahead and kick off today's webinar, which is running containerized applications on modern serverless platforms. Our speakers today are William Chia, who is in product marketing at Git Lab, and Ahmet Alpbalkan, who is a developer advocate at Google. Welcome, gentlemen. Thank you so much for joining me today.
Hello.
Hey, thanks, Charlene.
No problem.
We would love to kick it off with a poll just to ask a few questions of the audience, and we'd be happy to share the results as well to just see who's on the call today and how we can shape the content. So I think the first question we would like to know about is how often in your organization do you deploy to production? And so, you know, every 6 months or longer, maybe one production deployment every 6 months or longer, once per month or maybe once every few months, once per week or a few times per month, once per day, or multiple times per day in terms of where, you know, how often does your organization deploy to production? And it looks like most folks have entered in their choices. And I think, Charlene, can we kind of show the poll results?
Yeah, sure. Let me go ahead and close it out here and show the results. And there they are.
So it looks like the majority of folks on today's webinar are deploying anywhere from once a week to a few times per month. We have some folks who are deploying multiple times per day, and we have some folks that are doing one release, you know, every 6 months or longer. So a spread across with looks like most folks doing a production deploy about, you know, once per week. The next question that we have, if you can pop that one up, Charlene.
Sure, happy to.
Is which cloud providers are you using today? And so something we're definitely interested is, are you doing everything on-prem or everything in a private cloud? Are you using one of the major cloud providers, let's say, you know, Google, AWS, or Azure? Or are you using perhaps another cloud provider? And if you're using another cloud provider, feel free to drop in chat what are some of the other providers that you are making use of? And certainly feel free to check all that apply. We know some folks are using a single cloud provider, and some folks are also doing multi-cloud. And so I think it'll be kind of interesting to see how this data pops up. I have some guesses on how I think the graph will go based on where the industry is, but it'd be good to see where this webinar is. And I think if we can show the results here to the folks on the call, we can see who's on the call here. So AWS at 50%. What's very interesting here is about 40% or 39% of folks on the call are doing no public cloud, everything either on premises or in a private cloud, and some other types of cloud providers there. So that's definitely interesting. Just a couple more questions and we're going to kick into our content. The next question we'd like to know is about Kubernetes. And so you may or may not be familiar with Kubernetes. We will be talking about Kubernetes and give you a full introduction today on the call. And we're just curious, where are you at in your organization? Perhaps you're not using Kubernetes, not looking to use it, Perhaps you have some plans to use Kubernetes. Maybe you have started testing with it today. Or maybe you are doing Kubernetes in your infrastructure for production deployments. So it looks like most folks have answered the poll there. Let's go ahead and show the answers to the crew so they can also see who's on the call. This is pretty interesting to me. It looks like we have several folks, 30%, almost a third, using in experimental or non-production environments. And just a few who are not using Kubernetes, about 20%, 22%, or not planning to use it. But everyone else has some familiarity or is using Kubernetes. It looks like most folks are either planning to evaluate it or evaluating. And I think you're on the right webinar. We'll be talking about Kubernetes. The last question we have is the same question, but in regards to serverless. So of course, we'll be talking about serverless today on the webinar. And so the question would be, where is your organization at in terms of serverless adoption? And a similar question, either not using it, not planning to, let's say in the next 6 months, or some level of adoption. And today we'll be talking specifically about containers, using containers with serverless, but this could be any serverless technology, you know, Lambda or Google Functions. Where's your organization at? So it actually looks like votes are still coming in. I was going to say we could show these results, but we'll give another moment here. And I always think it's interesting when I tend to join webcasts as well. You get a makeup of the audience, and sometimes it's a little bit different than what you expect. So I think, Charlene, if we can close this one out and show it to the folks. Also interesting results. So this one pretty split across, with only 1% using serverless today in production. So definitely on the right webinar, we'll be talking about serverless. And if you're evaluating or looking to adopt serverless, this is what we're happy to share with you today. So with that, I would love to close down that poll and share a few slides here just to chat about what serverless is and give a bit of an introduction. So first, just to level set for everyone on the call, what is serverless? So really the way Ahmet and I are thinking about this are in terms of two components, an operational model and a programming model. So with the operational model, serverless is about not needing to manage any of your own infrastructure. So the traditional serverless services are things like Amazon Lambda, Google Functions, Azure Cloud Functions. And the idea here is you write a single function and upload that into one of these cloud providers. I'll show you what that looks like. So this literally can be as small as a single hello world function. This is an example from Google Cloud Platform, uploading to Google Functions. So you write the function. You can either put it into the web interface, as I'm showing here on the screen, or very often what you do is you will actually zip up that code into a zip file, upload that to the web, and then all of the operations is taken care of for you. So what the cloud provider does is it's event driven. When an event comes in, they will spin up the infrastructure to run that function. They will execute it, and then if there's more load, they'll process that load. But if there's, after a certain period of time, usually like 5 to 15 minutes, then it will actually shut down that infrastructure. What's really nice about the serverless model is it's a pay only for usage. That means if your app is getting hit with a lot of requests, the cloud provider will spin up more and more infrastructure to handle that load. It'll scale for you elastically, so you don't have to worry about load or any operations. And if there's no load on your app, it will scale all the way down to 0. So there's a lot of benefits here with serverless technology, and in particular, serverless functions. However, serverless is more than just functions. Often when I'm having conversations with various folks, whether I'm talking to customers of GitLab or users or folks at a conference, people tend to think of serverless and equate it with functions or functions as a service, what we would call FaaS. But really, serverless is so much more than functions. That's what we'd really like to talk about today. One of the things, and this is pretty common, is folks will say functions go together great with managed services. So also in the camp of serverless, if you were building a serverless application or a serverless architecture, it is almost certainly will include some type of managed services, again, usually from some type of either one of the major cloud providers or some type of SaaS provider that will give you either a messaging queue or a database, could be AI, or it even could be some amounts of compute that you're using to augment and manage your other services that are built on functions. And these types of managed services go really well together with functions, usually in a microservices type of architecture. But if you're using functions, they don't apply it for every use case, and there are some challenges. So when you start using serverless functions, one of the challenges are if you have an existing application and you want to move it into a FaaS or functions as a service platform, your existing app will need to be completely re-architected, and usually pretty dramatically. You would need to have that shift. That's one of the challenges. Another really, really big challenge, one that I hear extremely often, is that if you're using FaaS, there's a vendor lock-in. So if you write all of your functions on Lambda, and then later on decide you want to use Google Cloud Platform or Azure Functions, shifting between those platforms can be very, very difficult, especially the more managed services you consume. A lot of times they're very integrated, and there's not a lot of portability. It's just one of the things that comes along with using functions from a cloud provider. There's not a lot of portability there. Another challenge is if you are used to developing in a certain way, or your engineering team is most likely comprised of engineers who have a certain set of development skills, architectural patterns that they understand, programming with functions is a whole new paradigm to learn. There's a lot of things that you need to do differently than what you're used to. So those new paradigms can be a learning curve if you haven't done them before, or it can be difficult or expensive to procure, to hire developers that understand how to program with functions because it is new. Additionally, one of those challenges is if you want to do local development, very, very difficult to do when you're using functions as a service. The reason why is because you upload them to the cloud service, and then all of your different functions are interacting with each other. In order to replicate that entire cloud service in your local development is very, very difficult. It is possible, but it requires a lot of sophisticated engineering, usually setting some type of stubs and data type services that are sending you back pre-programmed responses. And it's really almost impossible to test locally. You could have some types of proxies where you're funneling production data down to your local development. You can see it's very, very difficult, very, very complicated. It is one of the challenges of using functions is it's just not going to be local development like you're used to. And finally, there are new architectural patterns to learn. So if you're used to building an application that runs in a virtual machine and it has certain components, in order to break that all out into a set of services is an architectural shift. And then in order to break those services into individual functions is another architectural shift. So learning that new architectural paradigm can be a challenge. With that, though, there is functions are good for a lot of use cases, but so are containers. And so I would like to pass over to Amit to share a little bit, and I will pass the screen share over to him as well, potentially. We have a lot more folks on the line now, so I noticed that Amit's in the list is farther down. There we go.
Okay, hopefully my slides are coming through momentarily. Okay, so thanks, William. This was a great introduction to functions. So when we think of serverless, we tend to think of pretty much functions and functions as a services only. But as William has said, containers actually give us that opportunity to pretty much do whatever we want in a way that we're already used to, right? So first of all, containers are portable. When you build a container image, it runs everywhere the same way. You can go from one cloud provider to another. Containers are flexible. You can use any language, framework, or the dependency that you like. If you wanted to actually run, let's say, a Fortran service on containers, you could totally do that, right? And finally, the containers are reproducible. So this gives us that flexibility to have something run locally the same way it runs on a cloud provider. So containers are this thing that we already had for a while already. So why are we not using containers, right? Why don't we just put our applications into containers and run them in a serverless fashion? So when we think about that, what is the best place to run containers? And this brings us to Kubernetes. And if you've gone through it already before, assuming you already know Kubernetes, Kubernetes is the de facto platform for running containers on a set of machines that you own. So Kubernetes was initially developed at Google, and now it is one of the most open source popular projects, right? So Kubernetes is not optimized for serverless paradigm. And let's talk about that a little bit. Why is Kubernetes not great? So first of all, Kubernetes does not have this notion of fast request-based auto-scaling. Kubernetes has a slower auto-scaling mechanism that lets you scale on CPU or memory, but it doesn't really have that notion of request-based auto-scaling. And another serverless property that we're seeing in functions as services is the scale to zero. For example, when you're not running anything, when you're not handling a request, nothing is ideally running. And we have this notion of request-based activation. So if you ever heard of the notion of cold starts, this is what we're referring to. Basically, a request comes into your service, and then your service actually starts and handles that request and goes away, ideally after a while. And finally, Kubernetes does not have this notion of events and event triggers. Like Kubernetes just runs containers, but it doesn't really know what is going on inside a container. It doesn't know anything about events. And serverless platforms like AWS Lambda, Google Cloud Functions, so on and so forth, they have this notion of events, which Kubernetes is lacking. And finally, you need to worry about actually operational aspects of running applications on Kubernetes. So for example, you need to worry about networking, load balancing, what is the process lifecycle, like how do I do restarts, how many replicas do I run at a time, like how do I set up auto scaling, again, as I mentioned earlier, how do I do my rollouts, and what is the memory / CPU that my container should be running with. Ideally in serverless world, you worry less about the operational aspects and you focus on the code, and once you deploy your code, the rest is pretty much taken care of by the infrastructure provider. So what we're saying is that at the end of the day, operators want Kubernetes. Kubernetes is great for orchestrating infrastructure and microservices. When we talk to operators, they just want Kubernetes. They want to have, hey, I have these machines. Can you manage them for me? So, for example, we have Google Kubernetes Engine, which is the managed Kubernetes service we have on Google Cloud. People come to Google Kubernetes Engine. They say, hey, give me 10 machines, and they get those 10 machines that are fully managed by Google Cloud. The problem, though, with Kubernetes is it's not the right abstraction for developers. Like if you're just a software engineer writing code, you have to go learn a lot about the infrastructure concerns and Kubernetes API, with best practices about Kubernetes, and so on and so forth. So the Kubernetes is not the right abstraction for developers for sure. So on the other hand, when we talk to developers, we're seeing that most developers don't actually care about the infrastructure and operations at all. They just want to write code that directly benefits their business. So they don't want to be in the business of doing operations. They don't want to be constrained by a framework or language. They want to have that full flexibility. They want to say, I want to use Python 3. I want to use Python 2. I want to use Java 8, or maybe like a Java version that is from 12 years ago. So they want that flexibility while still having something like a high-level platform that lets them deploy their applications, right? And finally, they don't want to manage the infrastructure at all. So most serverless platforms give them that. Like the reason why people like platforms like Google App Engine, Google Cloud Functions, AWS Lambda, and so on and so forth, the only reason they like it is you just write your code and the infrastructure gets out of the way. So why can't we have both? Containers give you that flexibility that you need. So what if we had an option to run containers in a fully managed infrastructure, but at the same time, we also have containers run easily on the infrastructure that you own? Because most of you are not directly, running on a fully managed environment. You're probably still running virtual machines. You're probably, running on bare metal machine servers that you have. So what if you had something like an easy way to run containers, like a Kubernetes cluster, but still have that serverless developer experience, right? So this brings us to the Knative project. I'm going to talk a little bit about Knative. I'm not going to go into too much detail. So Knative project is last year, something we announced last year, along with some partners like IBM, Red Hat, and Pivotal. So Knative project is an open source building blocks for creating serverless experiences on Kubernetes. So what does that mean? First of all, Knative has an open API that defines what the serverless experiences look like on Kubernetes or on any other platform. And secondly, it is an open source implementation. And I'm going to explain that in a little bit. So if you are interested in Knative, you can find more information on knative.dev. So let's see what Knative adds to the table, right? Brings to the table. So first of all, we have an open API on Knative. Knative is trying to standardize serverless containers. Just like how Kubernetes has standardized running containers, Knative wants to standardize the notion of having serverless containers and events on a Kubernetes cluster. So Knative has some properties that Kubernetes lacks that I mentioned earlier. For example, scale to zero or 0 to n, which is the fast request-based activation and scaling. And it has this notion of event sources, event handling, and event delivery. So if you already used Kubernetes before, or let's say roughly know how Kubernetes works, the power of the declarative APIs in Kubernetes come and manifest themselves on Knative as well. And that gives us a really powerful language to express serverless containers. So let's talk a little bit about CloudRun. CloudRun is a new product that is by Google Cloud. It is a serverless compute platform to run serverless containers. CloudRun is built from the Knative project that I just described. So we took an open source implementation and we pretty much re-implemented it internally so that we can run it internally. And then it uses the same API that is portable. So you can install Knative on your Kubernetes cluster and it would work the same way that we have CloudRun on Google Cloud. And we also have an option to run CloudRun anywhere you want. So let's dig a little bit into that. So why is CloudRun interesting? First of all, it lets you run any language, any binary, any library, because we're using containers, right? If you wanted to run COBOL containers in a serverless fashion, you could totally do that because it's container-based. And we know that you can install anything in containers. And it has still this pay-per-usage model that you have in serverless platforms. You're only paying when you're processing an HTTP request. So if you're not getting any requests, you're not actually charged. And on top of that, if multiple requests are actually overlapping, you're not double charged as opposed to some platforms like AWS Lambda or Google Cloud Functions. They charge you per request, but CloudRun doesn't charge you per request. It only charges you while you're processing an HTTP request. And thirdly, CloudRun can go from running nothing to thousands of requests per second really, really quickly. Like you can be running nothing and next minute you'll be handling 10,000 requests or more within just a few seconds without dropping any of the requests. So this is really powerful, and this is why people really like serverless. If you were managing servers, running from nothing to tens of thousands of requests will require you to provision a lot of infrastructure ahead of time. So we don't have that in CloudRun or other serverless platforms. And lastly, as I explained earlier, the CloudRun really gives you that option to choose where you're running. So we have two options, and I'm going to talk a little bit about these. One is running fully on Google's infrastructure, or running on a Kubernetes cluster that you already have or provided by Google. So as I said earlier, on the left you're going to see CloudRun. CloudRun runs your containers on Google's private infrastructure. Like you don't see any virtual machines. There are no instances laying around. You just give us the container and then we run it for you. So this is great for teams and developers that don't want to do any infrastructure and operations, and you only pay for what you use. And as I said earlier, CloudRun implements the Knative API. So this is again portable. On the right, I have CloudRun on GKE. So this is a flavor of CloudRun that is installed on top of Google Kubernetes Engine clusters. So Google Kubernetes Engine is a standard Kubernetes distribution, and then we add an add-on called CloudRun to it, and then suddenly your Kubernetes cluster is supercharged with serverless powers. So if you're already using Kubernetes on Google Cloud, by enabling this, you get that serverless developer experience of simply deploying containers, and you have that fast request-based activation and auto-scaling. You get all these superpowers that you're getting from Knative. And CloudRun on GKE actually uses the open source Knative implementation. It is not a re-implementation of the same API. It is actually just the open source Knative distribution. So both services give you the same developer experience, same API, same image format, and same command line interface. So they're practically the same thing. They're just running on different places. So CloudRun on GK runs on virtual machines that you have in your Kubernetes cluster. So instead of paying per request model, you're actually paying for the virtual machine instances that you already have. So what is CloudRun good for? So let's talk a little bit about this. If you have an application that does processing when a request comes, CloudRun is a great idea. So CloudRun doesn't support background processing. For example, let's say you have an application that wakes up every 5 minutes and does something and just goes to sleep again. CloudRun is not great for that. If you get no requests, we actually throttle your CPU almost to zero, so there is no background processing. There's only processing when you're handling requests. And CloudRun is great for going serverless without changing your code. Like if you already have a Python Java application out there, you can just put in a container, and then suddenly you're actually running in a serverless fashion where you don't have to manage any of the infrastructure, and you get all that auto-scaling capabilities out of the box. And lastly, let's say you want to move out of a container-based infrastructure that you manage, let's say Kubernetes cluster, because you want less cluster management. You don't want to deal with managing virtual machines. You don't want to deal with managing Kubernetes upgrades or operating system upgrades, or you don't want to deal with the system dependencies that you have on your environment. And you want faster auto-scaling. Again, this is like another reason to move out of Kubernetes to go to CloudRun. So lastly, I'm going to finish my presentation with a demo, and then I'm going to hand it back to William. So in this demo, I want to show a demo of what we've been discussing. So first of all, I'm going to walk you through a legacy application, and I'm going to explain why is this a legacy application and not a greenfield application. And then I'm going to explain how to put that in a container image using Docker, and then I'm going to go serverless from there. I'm going to deploy this container to CloudRun, and then I'm going to show you how this application runs on CloudRun on an endpoint that is HTTPS, and it's fully managed by Google Cloud, and it scales automatically. And then I'm going to take my application from CloudRun Google Managed Infrastructure, and then I'm going to put it to a Kubernetes cluster that I already manage. And then I'm going to take it from there, and I'm going to put it to another cloud provider just to show you that Knative is portable and it's vendor neutral. So I'm going to exit my presentation right here, and I'm going to walk you through the application that I've been mentioning earlier a little bit. So this is the PDF application that I already have. As you can see, this application basically converts doc files to PDF. And let's see how it does that actually. So I have this Python application here. Let's click to it. And the gist of this application is basically down here. I have a function that basically calls OpenOffice or LibreOffice. And as you know, LibreOffice is like 10 years old software, and it's probably written in C++, and I'm invoking this from a Python application. So the way I do that is I go back and I'll show you this Docker file, which is the file that we use to build containers. So this basically says, hey, I'm going to use a Python image, and I'm going to add LibreOffice to it and a bunch of other dependencies that you normally wouldn't be able to install in a serverless environment. And then finally, I'm going to run this server application. So if I go to my demo environment, so this is the Google Cloud Platform console if you're not familiar with it. So let's go to this PDF directory. And the way you build this application is you type docker build, and then you basically specify where you want to build this image. And then Docker goes ahead and kicks off a build. So I'm not going to wait for this to complete. I already built and pushed the image for the sake of this demo. So next, I want to show you how to deploy this to CloudRun. Again, CloudRun is that environment that I deploy containers that are HTTP based, and it's fully managed by Google. I don't have to do any operations whatsoever. And to show how that actually works, I'm going to click Create Service here, and I'm going to type the same container name I just described earlier. And once I type that, it basically says to me, where do you want to deploy? Do you want everyone to access it? And I'm going to check these boxes, and I'm just going to hit Create. So once I do that, what's going on right now behind the scenes is that Google's managed infrastructure is downloading my container image, and it's using the infrastructure that is already provisioned by Google to serve this traffic. So, in less than, say, 15 seconds, the application is actually deployed. And I get an fully HTTPS endpoint from Google. And once I click to it, after a few seconds of cold start, hopefully my application is going to load. It seems like, this is the application that you use to convert a doc file to PDF. So there's an example down here. I'm actually going to click to it. And it's probably going to download that doc file first, and then it's going to convert that to PDF. Again, this is a container that runs OpenOffice in it. And normally, if you're running on, like, say, Google Cloud Functions or AWS Lambda, which is, what we traditionally associate as serverless, you wouldn't be able to do that. So now you have that ability to do this on Google CloudRun. So it seems like my document has actually been converted to PDF just fine. So I'm going to go back, and I'm going to show you that here I have this Kubernetes cluster on Google Cloud again. It's called the GK cluster. And what I want to show you is I'm going to click on this cluster, and I want to show the add-on that I mentioned earlier that is already installed in this. So if I scroll down here, it basically says add-ons here. You see, it says CloudRun on GKE. So this is that thing that makes my GKE cluster run this CloudRun applications the same way I run them. So if I go back here, go back to my console again, let's take this demo application again, and then I'm going to deploy another service to CloudRun. But this time, instead of deploying to Google's managed infrastructure, I'm going to deploy it to the GKE cluster that I already have. So if I go ahead here, and if I click on the location, you're going to see that there's a US Central one, which is fully managed by Google. But I also have a GKE cluster that I can deploy to. So the same way I deploy this application. So what's happening right now is I'm using the same API or same command line experience or same UI to deploy to both platforms. And again, in a few seconds, this application is already deployed to GKE. So if I click on the URL that it gave me, I get the same experience. If I click to the same demo, the whole thing works the same way because it's containers, right? So let's take a little bit behind the scenes of what is actually going on here. So if I come to my Cloud console here, if I say gcloud beta run services list, let's type that correctly, bunch of warnings, you're going to see that I have this PDF service. So if I say gcloud beta run services describe, because I want to see what's going on inside my service. And I'm going to say I'm running on the managed platform, and then my location is US Central 1, and I have this application called PDF. So if I take a look at the output of this command, I'm basically seeing this YAML file, which is oddly familiar. It has API version, it says kind service, it has metadata. If you already use Kubernetes, this is because this is a Kubernetes object running on Google's infrastructure. So what I'm going to do is I'm actually going to save this thing to a file called service.yaml. Okay, so let's take a look at this service.yaml. And what I'm going to do here, first and foremost, is I'm going to delete a bunch of things that I already don't need. So for example, I'm going to do all these lines just to show you what is going on here. All right. So at the end of the day, what's going on here is that this is a simple Knative service description. It basically says that I have this image and I have this memory constraint, and these are my timeouts, etc. Please go run this application for me using the Knative API. So lastly, as I said earlier, I'm going to go ahead and deploy this application to IBM's cloud. So if I go to IBM Cloud Console here, you're going to see that I have a cluster here called Knative cluster. Let's click on this. Just like what I have been doing at Google Cloud, I actually installed Knative to IBM Cloud as well, but I didn't do it myself. Like, I didn't go ahead and manage this Knative installation. If I click to the add-ons tab up here, you're going to see that IBM Cloud also has a Knative distribution, just like Google Cloud does. I actually went and enabled manage Knative, which gives me the serverless capabilities on my Kubernetes cluster. So you're seeing that I have the same functionality on multiple cloud platforms, and it's open source, and it is open API, and it is portable. So if I go back to my console here, and if I say, if I point my kubectl command to the IBM cluster, let's run kubectl get nodes here, and then you're going to see that it says IKS here, which means IBM Kubernetes Service. I'm actually right now targeting IBM Kubernetes Service. So if I go ahead and kubectl apply the service YAML that I saved earlier, you're going to see that the service is actually now deployed to IBM Kubernetes Service. So if I do kubectl get services, I'm going to get this domain name that is pretty long, but it is from IBM Cloud, and it also works the same way. So if I go ahead and open a new tab and deploy this application, yep, if I visit this application, I have the same application again, the same container, this time running on IBM Cloud. So it took me like 5 minutes to go from something that I have locally to Google Cloud, and then to Kubernetes, and then from there I went to IBM's Kubernetes cluster. So this is pretty much all I wanted to show. Again, Knative is that open API and open implementation that gave me that functionality. So now I want to hand it back to William.
Okay, that is great, Ahmet. Of course, this is a phenomenal developer experience that you've seen. Developing locally, I want to have my application deployed. Ahmet showed how to do that through the UI, which is just a few clicks, but there are also really nice command line tools for CloudRun that'll allow you from your shell to do these kind of same deployments with just a few commands. Of course, at some point when you scale, you'll want to automate your deployments, and then you really want terrific CI/CD. And so what I would like to share is that most folks are familiar with GitLab as a code hosting service. So a lot of you folks on the call have your code on GitLab. You saw in Ahmet's demo the code that he was deploying was hosted on GitLab. But what you may not know is that GitLab also has world-class CI/CD. In fact, many analysts and enterprises have written about our CI/CD capabilities as world-class CI/CD. So when you're ready to automate those deployments, GitLab has tremendous CI/CD. What you may not know is that GitLab also has a whole slew of other capabilities, everything from project management through to release management, configuration, even monitoring and security capabilities. So what you're seeing on the slide right now is actually a screenshot of our homepage that shows all the categories that we have functionality in, and even some that are coming up on our roadmap. So one of these that you will see is that within our what we call the configure stage of the DevOps lifecycle, our goal is to have a single application that covers the entire lifecycle. We have serverless as functionality. And so the GitLab Serverless is a way for you to actually have your own functions as a service, your own FAS, or even your own container service built into GitLab. So the advantage here is whether you are using vanilla Kubernetes that you have provisioned yourself and are running on your own on-premises infrastructure, whether you're using Kubernetes that you've built yourself and are running on cloud infrastructure, or maybe you're using a managed service like IBM or GKE that you've seen, wherever your Kubernetes cluster is, you can connect it to GitLab. And GitLab Serverless can actually deploy your code into that Kubernetes cluster, and using Knative will allow it to scale up and down as you've seen described. So what I would like to also kind of show you this demo of how that will work. You can think of your infrastructure can be anything from bare metal to any cloud service. You are going to have a Kubernetes cluster running on top of that. For the purposes of my demo, I'll show that with GKE, but on GitLab, it can connect to any Kubernetes cluster. And this is one of the really powerful elements of these types of technology, is just that portability. You can decide where you want it to run, and you are even able to shift where that runs, even have it run in multiple places as multi-cloud. We will be using the Knative APIs for the serving and eventing, and in this case, this is what CloudRun provides. I'll show you how you can install that via GitLab, or you could use CloudRun, and then of course GitLab Serverless, that's going to provide you this concept of functions or applications, whereas Kubernetes doesn't have these types of scaling capabilities. That's why you need Knative. And Knative does not have the concept of a function. But within GitLab, you can actually write a single function and have it scale. Or, as you've seen a container, you can have a container and have GitLab Serverless deploy that. And that's what I'd like to share with you over here, potentially. So here I have a project that I have already set up on GitLab, and you can see this is the same code that you have already seen in terms of this PDF application, where it has a bit of Python and it's calling out to LibreOffice to do the conversion. This is the same code that Ahmet is running. The only difference is I've made a commit here to add a CI YAML file. And as I mentioned, GitLab has CI/CD to allow you to do this automation. And the way that you configure that CI/CD is via some simple YAML. And this is very powerful because it means you can version your CI/CD configuration. It means you can have multiple people collaborate in the same way you would collaborate on code. You can roll forward and roll backward and have accountability and auditing, etc. Now, this GitLab CI YAML file is extremely simple, and that's because it is using the GitLab Serverless template. So within GitLab CI YAML, you can import a template and then extend it if you'd like. And there are several templates that just come baked into GitLab, and the serverless template is one of those. So you can see all I'm doing here is importing or including this serverless template, and I'm going to create two stages. I'm going to have a build stage of my pipeline and a deploy stage of my pipeline, and both of those are making use of a serverless image that just comes baked into GitLab. In a nutshell, GitLab Serverless really is the CI YAML templates and some visualization capabilities that I'll show in a moment. So this is the same code you're familiar with, and in order to deploy this code, I of course want to connect GitLab to my Kubernetes cluster. So I'll go to the Operations tab and go here to Kubernetes. When I go to add a cluster, I have a few options. So one is, if you are not familiar with Kubernetes, this is a nice way to get started. We have a great integration with GKE where you can literally sign in with your Google account, name the cluster, and GitLab will actually go and create the cluster for you on GKE. So if you're new to Kubernetes or want an easy way to spin up a quick cluster, the GKE integration does that nicely. Or if you have an operations team that is already managing your Kubernetes cluster, you can attach any cluster here. You can see I've already attached a cluster, and what I've done with this cluster is I've already created a cluster here, and I've one-click installed some of these add-ons. So GitLab can also help you manage things like Teller, Helm Tiller, Prometheus, which is going to do some monitoring for us, and of course Knative, which we're going to use for those serverless APIs. I've set my own domain here, and what you can see is I can then run a CI/CD pipeline. So when I actually run my pipeline, here is my build, and here's my deploy, and we can actually look. This is GitLab CI/CD when it runs that file. You can see here's the build script that it ran. If I had any artifacts, I could download them here. And then, of course, it is also going to allow me to go and look at the deploy stage. So I've deployed this using GitLab Serverless. What that will do is not only deploy it onto my infrastructure and give me an endpoint URL, but here I have some visualizations I talked about. So what GitLab is doing now is it's querying my Knative service, and it sees like I have an application. I've named it this service, and here's my endpoint. So if I visit the endpoint, you will see here's the cold start we talked about, where in this case it'll take anywhere from a few seconds to there's no pods spun up, right? There's no container. So from zero, spun up this container, and now here's the same application we've seen a few times. Of course, now that it's live and running hot, it will spin up very quickly with new requests. And I can go into GitLab and see some of the visualizations on this page. So for example, it will show me a request graph here of those requests that I just did. And there it is using the Prometheus monitoring. So this is some of the integration you see between GitLab and Kubernetes. Of course, what we have today is if you want to use all of this together with CloudRun, you can use CloudRun on GKE, and CloudRun will install your Knative cluster when you Knative to your cluster. When you attach that cluster to GitLab, GitLab will actually detect Knative and will be able to use GitLab Serverless all running just the way you've seen right now. But in the future, we do also have some roadmap where we want to enable you to also be able to one-click install Knative on GKE. Of course, GitLab, we like to keep everything very transparent, kind of unique. So you can go to our homepage. This is literally about.gitlab.com. You can see here is our roadmap for each of our stages. We link to our roadmap, and you can click here to see what's coming up, and that's how you can get to learn more about when even more integration between GKE and CloudRun will be coming. So with that, I would like to stop sharing my screen And Charlene, I believe that while we've been chatting here, we have some folks that have been asking questions along, and we would love to just do some live Q&A to see what folks on the call want to learn about.
Perfect, perfect. Well, yes, we have gotten some great questions in, but there's plenty of time, guys. If you have a question, let me put myself on webcam. If you have a question for any of our panelists, please go ahead and use your GoToWebinar control panel and submit your question. Okay, first one is, let's see, really cool presentation and examples. So yeah, let's assume I have a container running some Node.js front end, which takes a while to start. That would mean the cold start from serverless would be pretty slow, causing a bad user experience, right?
I can probably take that. Yeah, that's true. So that's a property of serverless. Although it's negative, there are cold starts. And that happens mostly because when you're not getting any requests, you're not really running anything. So it takes actually some time to start your application. On Google Cloud Run specifically, we have optimizations, such as we actually cache the image so that it doesn't have to be re-downloaded when a request comes in. As long as your application startup is pretty fast, it'll probably be a couple of seconds before the first request is processed. But there are again ways to keep applications quote unquote warm. You know, it's the same stuff that you've already used from the serverless land. So it's the same stuff.
Yeah, I would say my general advice there is there are use cases that are really good for serverless if something is event-based. One use case I will talk about is you sign up a new user, and let's say you need to do some processing. They've uploaded their image, and you need to go crop that into different sizes for parts of your app. You need to, let's say, create some other account details. That type of asynchronous event-based processing, really, really good for serverless workloads. Things kind of like the example we showed was a little bit contrived because that was a web page that users would visit. And that's not the best experience because if you have that cold start, it is going to take some time, and so you don't want your users to see that. So that's kind of my advice there is if it's a long-running service or if it's a user-facing service, just running that in a regular container on your Kubernetes cluster is an always-on service. That's a really, really good for those workloads. And for anything asynchronous and event-based, running that on serverless.
Awesome. All right. Great. Next question. Let's see. Do I need to use GitLab for everything, or can I use GitLab together with tools like Jira and Jenkins? William, where have you gone? There you are. We lost you for a second.
So we get this question. I get this question pretty often when folks kind of see that homepage image I showed. Again, they're familiar with GitLab. I host my code there, but wow, you do all of these types of things like project planning and whatnot. And so the question is usually, let's say I'm already using tools for that. Let's say I already have Jira for my project tracking, and let's say I already have my pipelines, let's say in something like Jenkins. Can I use GitLab just for my code repository? And the answer is yes, you can. In fact, at GitLab, we try to play well with others. So you can, for the most part, use any component of it as a standalone. So what a lot of folks even do now is they will use our CI/CD tool, and they will have their code hosted on GitHub or Bitbucket and use GitLab just for the CI/CD. So you don't have to replace your entire tool chain, although if you do use GitLab end-to-end, because it's so tightly integrated, there are some kind of neat meta benefits that you see, and we'll chat about that on a different webinar.
Awesome. All right, great. Next question. Can you explain a little about events? What are they for?
Yeah, I can probably take that. So events are stuff that are happening outside your application, and it comes to your application, essentially. You can think of events like I just uploaded a file to a storage bucket, and then I want my application to get called when a file is uploaded to a storage bucket. That's like the cliche example of serverless events. But another example could be like, let's say my build has failed. So I want a webhook so that my application should be called when a build is failed. So I can do something like maybe post it to Slack or post it to, open a ticket, maybe something like that. Or another example of events could be, let's see, maybe like IoT is a great example. When something happens on an IoT device, you want to do something on cloud. So if your IoT device emits an event, says, let's say, light turned on, you might want multiple applications to get triggered when that event happens. So events are basically just asynchronous actions that are happening outside your application, and your application as a result gets invoked as a result of that. William, do you have anything to add?
No, I think that's a great description. You can think of any type of time you'd receive an API call or webhook as Ahmet described, or ones that are very, very common are when you have some type of queue processing, for example, uploading the S3 bucket, or you have some amount of things in a queue. Each time something pops off, you can go and process that event with a serverless workload.
I think an interesting example of events here is, I'm going to add a little bit, is that let's say a video is uploaded to a storage bucket, right? Let's say you're getting hundreds of videos. Normally, you would implement an application that would dequeue from the event source. But in serverless case, what's happening is that you can, let's say 100 videos are uploaded at the same time. You can just spin off 100 containers to process these videos and then put it back to storage again. So basically, instead of scaling that application, the worker application yourself, serverless does that for you. And that's probably the difference between normal queue-based applications and serverless.
All right, great. So many good questions here. Okay, next question. How large, as in gigabyte, can the function script and its dependencies be in order to run on GitLab Serverless?
That is a great question, and I will admit ignorance that I don't think that there is an upper threshold there. So, for example, there's kind of two components to GitLab Serverless. One is what we would call a function, and one is what we call a serverless application. The only difference being with the application, you're specifying your own container. As you saw in our demo, we had a Docker file, and you specify that image, and then GitLab will just run that. And for the purposes of that, I would say anything that you can containerize, you can run and scale. And I'm seeing Ahmet shaking his head that it's going to be the same way on CloudRun. Is that right, Ahmet?
Yeah, so basically what you did there was building an application that the resulting container image was actually around 800 megabytes, I think, because we installed LibreOffice and a bunch of other fonts and stuff. So yeah, you're right.
So if you think of a typical function, there tend to be size limits on what you can upload in that zip file, and can't remember them all. They're probably a little bit different for the different platforms. But this is another advantage of containerizing the workload is you could containerize in all of LibreOffice and run a PDF translator. That's kind of one of the advantages there.
All right, great. Okay, let's see. We're about 8 minutes to the top of the hour, so I think we can get to one or two more questions here before we close things down. Okay, so what version of GKE has Knative add-on enabled? I don't see this option in my 1.136.6 GKE.13 cluster.
Yeah, I think the person said, sorry, typo, it's 1.13.6. So
Right.
This is a beta add-on. If you go to the documentation, it documents which versions it's available on. I know that it's not available on some of the older versions. I don't remember off the top of my head, so I'm just going to say sorry. Please look at the documentation.
Excellent. Okay, great. Next question. Okay, you need one container for each request. I think this is maybe an add-on to an earlier question. And what uses Knative to scale?
Yeah, so I can quickly probably answer that. Knative can actually reuse containers, and so does the Google managed CloudRun platform. So if your container is a, let's say, Go application or C++ application that can handle thousands of requests at a time, we will send however many requests that you want to your container at a time. So for example, if you want your container to get only one request at a time, you will basically spin up another container for each request as long as the other one is occupied. But once the other one is free, we're just going to reuse that. So how does Knative scale? I think the answer to that is Knative actually looks at request metrics. It internally uses Prometheus and a few other things to keep track of the requests. Because all requests are going through Knative, Knative actually knows what's going on, and it can do really fast scaling based on a immediate need for scaling. So if it realizes it's in a panic mode, it will add a lot of containers for a while, and then it'll over time correct that.
Okay, great.
And some of that is configurable as well. Again, maybe for another webinar, but you can actually look at the Knative documentation. And if you you are an operations person, or this is your bag of tricks is you do like administering Kubernetes cluster and applying YAML files, then you can even you can configure and set some pretty granular parameters on how and when Knative will do the scaling for you.
All right, great. Well, we're about 5 minutes to the top of the hour, so we're going to go ahead and close out the question and answer period of today's webinar. We had a ton of great questions, and if we didn't get to your question, I apologize, but I'm sure somebody from Google or GitLab will be more than happy to follow up with you and get your question answered. So before we close things down, do want to do the drawing for the $3 $50 Amazon gift cards. So our first winner is, let's see, Tom Westrick. Congratulations, Tom. Next person, big winner, Mari Federo. Congratulations, Mari. And finally, drum roll, please, Ish Kapila. Congratulations, Ish. Thank you all for being on the webinar today, and I'm sorry if you weren't one of our big 3 winners, but maybe next time, Before we close things down, I do want to remind the audience that today's event has been recorded, so if you missed any or all of today's event, or if you just want to watch it again, you will be able to do so. We're going to be sending out an email a little bit later on today that includes a link to the event on demand. And the webinar is also going to be living on the devops.com website, so you can always find it there. Just go to devops.com/webinars, look in the on-demand section, and it will be right there waiting for you. So William and Amit, thank you both for giving such a great presentation. Judging from the types and the number of questions we got in, I know the audience got a lot out of it, so thanks so much.
Thank you.
Okay, thank you.
Great, great. Want to thank the audience also for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.